Alright, so in this video we're going to be looking as to how we were creating our models. So now we have looked at as to how we created our front end, as to how we were creating our back end. Now we are going to look as to how we are going to be creating our ML model, given that you already have the data set. So if I show you the data set, this is the data set that we will be working with over here. So we have ID, sepal length, your sepal width, your petal length and petal width, and we also have our species over here. Um, okay, so we are going to create our new file and we're going to call this create ml model.ipynb file. So this is like a Jupyter file. We're now going to activate our project, or not our project, but our Honda environment. So there is a list of libraries that I need to import. So give me a second and I'll import that. So these were the libraries that you require. I've already installed them to save up some time. So the first thing that we're going to do is we are going to read our data set. So we're going to say df equals to df dot pd dot read underscore csv. This is going to be in dataset or dataset.csv file, and then we're going to do df.head to see the first 5 rows. So we have our ID, sepal length, sepal width, petal width, species. We can look at the maximum value of df sepal length, and that will be 7.9. So this is the reason why I was saying that the maximum value we have kept as 10. And we can also look at the minimum value, like it's 4.3, but it's best to say that we can keep like a value of 0, and there aren't going to be any negative values in this data set. So that is the reason why our minimum and maximum value over here was set to 0 and 10. Okay, so moving on. Now what we are going to do is we are now going to train our model. The reason as to why I was using iris dataset is because it doesn't requires any cleaning, any transformation. It's very easy to use. So now we are going to define our um, x features and y prediction variable. So our x features are going to be these 4 things. We are not going to be using the ID because it's not meaningful for us, and we are going to use our species as our Y. So you can do this in any way you like. The way as to how I'm doing this by using iLog, because I know that I require all of the rows and I only require columns 1 to 5, which is 1, 2, 3, 4, and this fifth one will not be included. And my y is going to be df.species, and if you want you can write x.head and you will find that I have these 4 columns over here. If you want you can also write y and you will get all of your y species. Now what we're going to do is we need to encode this into either 0, 1, 2, because string is not acceptable for any machine learning model. So it's better to encode this. So for this we are going to be using label encoder. So I'm going to write label encoder object is going to be called label underscore encoder, and we are going to now encode this. So label underscore encoder dot fit transform, and we're going to encode this. So now if I look at y, you'll see that it now is it's an NP array with value 0 denoting the first class. If I show you the entire data set, so df, so you'll see that it has 3 different classes over here. It has setosa, it has versicolor, and the third is virginica. So the Setosa is set to 0, the versicolor is set to 1, and the virginica is set to 2. So over here, the encoding has been done. The next step is to train our model. So to train our model, we're just going to write model equals to xgb dot xgb classifier, and inside this we're going to set our evaluation metric to be mg loss, mg log loss, m log loss. I don't know why I call it mg log loss. So this is mean log loss, and we're then going to train our model. So we're going to train, but before we train the model, we need to split the data set into train and test. So to split our data set, we are going to say that uh, our x train comma x test comma y train comma y test is going to be train test split. This is a function by your sklearn library, so it can split your entire this data frame into training and testing data set. So we want to define our input as x, our output as y. We want to set our test size to be 0.3, which means that 30% of our data set will be the testing data, 70% of the data will be our training data. And we want to set a random state to be as 42, which means every time that I'm going to execute this particular function, I'm going to get the same training and testing data set. If you do not set this, if you set this to some other value, then it will be set to some other random seed. So we have our x train, x test, y train, y test. Now we're going to fit our model. So model.fit, we're going to specify our x train and our y train over here. So this will basically create your model. The model has been built. It's very easy, very simple, not that difficult. And next, what we're going to do is now write the code for inference. So before I write the code for inference, let's write our code for inference. So inference is going to be y prediction, and this will be model.predict, and we can take any value from our x test. So if you look at x test over here, it's this data set over here. And if I want to grab any one of these rows, I can just write this as 0. So this will return me a single row, which I have to transform a little bit, because I need to apply dot values. Still won't get this. I need to apply reshape to 1 comma negative 1. So 1 comma negative 1, and now I can't get it. Why can I not get this value? Because I had to write ilock. This is the reason why. Dot ilock. We got this. If I remove this, I will get, okay. So if I write x dot test dot ilog 0, this is returning me the first row. So integer locking, right? So if I lock the first 0th row, I will get this data set, this data over here. If I write 1 over here, I will get the second row, which is this thing. But if you look over here, when we were training our model, the model was using an NP array. Okay, so we need to specify this as values dot reshape 1 comma negative 1. When you do this, this now becomes a two-dimensional array, and this is what is going to be accepted by your model. So if I go over here and if I write ilock 0, it will give me an error, okay, because it says that it is missing some values, and it does not make sense. But if we now write this as values dot reshape 1 comma negative 1, it will work. And if I want to predict or show you the prediction, it will be shown as an array. And if you want to get the first prediction, that will be 0. So if you remember over here, we were doing the same thing, which was that we were getting our data inference in a two-dimensional array because of this. And then when we wanted the prediction, we were using to get the first prediction. So this is the reason why as to why this was happening. All right. So now that we know as to how we can do our inferences, now we are going to create our model. So I can go ahead and I can delete both of these models. And now let's try to create our own pickle files and joblib files. So first of all, I'm going to do it with the pickle file, and then I'm going to do it with a joblib file. So to create your model using pickle file, we're going to import pickle, and then we're going to say that our pickle file path uh, is going to be xgb underscore model dot pkl, and then we are going to say with open pickle file path, and we're going to write this as wp as f. We are then going to write pickle dot dump, and we are going to specify our model, which is what we have created over here. So we're dumping our model in this file f. So if I run this, you will see the pickle file has been created. And now if I write test data equals to this thing over here. So our test data becomes this thing. I can remove this from here. Now I'll just write what I was writing in the previous code, which was um, that pickle dot sorry. So we need to load the model. So import pickle. I can just copy the code from over here. Uh, okay, load the file, and then we don't need this right now, and we can just write that our prediction is going to be test data, and then we can just write prediction and see it is working over here. All right, so this was for 1. Let's do it for 0. We should get 1 as well, so we are getting the same prediction. So this is working. So this was for your pickle file. um, Now we're going to create our uh, joblib model. So to create our joblib model, we're going to import joblib, and then from joblib, we're going to import both the load and the dump function. We are going to specify our path. So the path is going to be the same as this, but we're just going to call this joblib. Let's call it joblib. Now we can write joblib dot dump the model, comma this thing. We can run this, and we got our joblib file. Now let's see if this is working or not. Let's import this. So we can just write uh, our model, or let's say that our joblib model is going to be joblib load the joblib file path, and then our prediction, the prediction is going to be joblib model dot predict for our test data, and then we can print out our prediction, and we get the 0, and we get 1 again. So that is it. um, in this series, I will be telling you more about as to how to create a software where you are integrating a machine learning model. So this is going to be mostly based on your software development and machine learning projects. Um, in There will be another series as to where I will be going into the entire theory of this, explaining into the depths of as to how an XGBoost is working, into going as to explaining what are the different parameters you can mess with over here, how to do hyperparameter tuning. But in this series, we're only focusing on as to how you're going to create the front end, back end application. How are you going to integrate your machine learning model into it? How can you deploy this on any cloud website, and as to how you can add MLOps to this project as well. So all of that will be covered in later videos. So now that we have um, looked at as to how we were creating our ML model, the next step is to now remove another assumption, which is going to be our step 4, and that is, how did we get the data set? So mostly, whenever you're doing like normal, simple machine learning projects, you will be given a data set. But whenever you're working in a professional scenario, this is not the case. You need to fetch the data set. So in our case, what we are going to do is we're going to be scraping the data from a very easy dummy website, just to show you as to how the flow of collecting the data set is. So we will be now looking at as to how to integrate an ETL pipeline. ETL pipeline. I will be explaining as to what is the ETL pipeline in the next video. How to use an ETL pipeline to collect your data set so that you can use that for your ML model. So as you can see, step by step, we are now slowly adding more and more complexity to the problem, and we are now giving you more freedom as to how you can collect your own data set, how you can create your own ML model, how can you create your front end application, your back end application, and integrate your machine learning model in those applications. So that is all. See you in the next video.